Welcome to our deep dive today.
Okay.
We're going to be exploring the world of Andrew G. Barto.
All right.
A real pioneer in artificial intelligence, especially in the field of reinforcement learning.
Yeah.
We've got excerpts from an essay titled Andrew G. Barto, Shaping AI Through Reinforcement Learning, which really digs into his theories and work and collaborations and all that good stuff.
Well, what's fascinating about Barto is that he kind of emerged during a really interesting time for AI.
Yeah.
The 70s and 80s,
Okay.
AI was booming, but also hitting some walls with the dominant approach at the time, which was all about symbolic AI.
Okay.
You know, basically programming machines with tons of rules. Barto, however, was captivated by this idea of machines that could learn autonomously, interacting with the world and figuring things out on their own.
So instead of just following instructions, he wanted to build machines that could kind of learn like we do.
Yes, through experience. He saw the potential for machines to learn through trial and error, adapting their behavior based on the feedback they get. Much like how humans learn from experience.
Yeah, that must have been a pretty radical idea back then.
Oh, yeah.
So the essay mentions he had a background in both math and computer science.
Right.
Was that unusual at the time?
I think that was a really powerful combination.
Okay.
You know, that strong mathematical foundation was essential for developing the algorithm that would drive reinforcement learning. While that computer science background enabled him to actually translate those mathematical ideas into working systems.
So it sounds like he was in the right place at the right time.
Yeah.
To really make a difference.
He was.
The essay highlights his collaboration with Richard S. Sutton. So were they kind of like the founding fathers of reinforcement learning?
They were definitely pioneers. Together, they've formalized many of the core concepts and algorithms that we now define reinforcement learning as we know it today. They wanted to build AI that wasn't limited to following pre-programmed rules, but could actually adapt and learn from its interactions with the world.
So what exactly is reinforcement learning, or RL?
Wow.
I have a feeling it's a little more than just teaching a computer to play fetch.
You're right. It's far more sophisticated than that. At its heart, RL is about an agent, which could be anything, from a robot to a piece of software, learning to make decisions by interacting with an environment. The agent takes actions, the environment responds, and the agent receives feedback in the form of rewards or penalties.
So it's all about rewards and consequences.
Yeah.
Kind of like how we train a dog. Give it a treat for good behavior. Maybe a firm no for chewing on the furniture.
Exactly.
But what makes RL different from other types of machine learning? Like supervised learning.
Well, with supervised learning, it's like having a teacher tell you the right answer for every problem. RL, on the other hand, is more like figuring things out on your own. The agent doesn't get explicit instructions. It has to explore, experiment, and learn what actions lead to the most rewards over time.
That's where the reinforcement part comes in.
Exactly.
It's about reinforcing those actions that lead to positive outcomes.
Precisely. And it's not just about immediate rewards either. One of the key principles in RL is this idea of maximizing cumulative reward. The agent is always looking ahead, trying to figure out what sequence of actions will lead to the biggest payoff in the long run.
So it's kind of like thinking strategically, planning for the future.
It is.
But in a mathematical way.
Absolutely.
The essay did mention that math plays a big role in all of this.
There are equations that describe how the agent learns and updates its strategies based on the rewards it receives. But think of it this way. The math is the engine that drives the learning process. Helping the agent to make smarter and smarter decisions over time.
It sounds like Barto and Sutton were really laying the groundwork for a whole new way of thinking about AI.
They were.
So what were some of the big breakthroughs they made? That really put reinforcement learning on the map?
Well, one of the most significant was temporal difference learning, or TD learning.
TD learning?
Yeah, I'm intrigued.
It revolutionized how AI agents learn from experience.
What makes it so special?
Well, the magic of TD learning is that it constantly updates its predictions based on each new bit of information it gets. Like a detective.
piecing together a mystery as clues come in. It doesn't have to see the whole picture to start learning and adapting.
Gotcha.
And this is hugely important for making RL work in real-world situations, which are rarely neat and predictable.
It's about learning on the fly.
Exactly.
Constantly adjusting your expectations as you go.
And this ability to learn from incomplete information makes RL incredibly powerful for tackling those real-world problems where things are constantly changing.
Now, another game changer Barto was involved in was Q learning.
Right.
Q learning. Does the Q stand for something?
Yeah.
It sounds like a secret agent code name.
It's almost as cool. Q stands for quality.
Okay.
It's about figuring out the best action to take in a given situation to maximize those long-term rewards we talked about. And what makes Q learning even more impressive is that it's a model-free algorithm.
Yeah. So no instruction manual.
Exactly.
Okay.
Think of it like playing a video game for the first time.
Yeah.
You don't have a manual.
Right.
So you have to learn by trying things out and seeing what works.
So it's learning by doing. Even when you're starting from scratch.
Exactly.
Okay.
That's Q learning in action.
Like figuring out how to ride a bike without training wheels.
That's a great analogy.
Yeah.
And it kind of highlights another fascinating aspect of Barto's work.
Yeah.
His interest in the connection between AI and how animals, including humans, learn.
So he was drawing inspiration from biology and neuroscience.
Absolutely.
Okay.
He saw reinforcement learning as a way to not only build smarter machines, but also to understand how our own learning processes work.
So, for example, the TD error we talked about in TD learning.
Yes.
That actually mirrors the way dopamine works in our brains.
It does.
Dopamine, the feel-good chemical.
Right.
What does that have to do with AI?
Well, dopamine signals whether something was better or worse than expected, which helps us to learn and adjust our behavior. It's very similar to how TD learning in AI adjusts predictions based on the difference between what the agent expected and what actually happened.
So there's this deep connection between how our brains learn and how these AI agents learn.
There is.
Through reinforcement learning.
It's a fascinating parallel, and it really highlights the interdisciplinary nature of Barto's work. He wasn't just building algorithms. He was trying to understand the fundamental principles of learning itself. Drawing inspiration from both computer science and biology.
It's like he was reverse engineering the brain.
Yeah.
To figure out how to build smarter machines. It's starting to make sense why Barto is considered such a visionary in AI.
Yeah. He was ahead of his time. In so many ways.
All right, so we've established Andrew G. Barto was onto something truly groundbreaking with reinforcement learning.
He was.
But what did his work actually look like?
Right.
I mean, besides collaborating with others, he must have published a ton, right?
Oh, absolutely.
Yeah.
Barto has an impressive list of publications that have really shaped the field of AI. And his work isn't just historically significant. It's still incredibly relevant today. In fact, so much of what we see happening in AI now is built upon the foundation he laid.
That's incredible staying power.
It is.
So the essay mentions his book, Reinforcement Learning, an introduction co-authored with Richard Sutton.
Yes.
So is this like required reading for anyone getting into RL?
It practically is. It was first published back in 1998 and then updated in 2018. It's kind of like the Bible of reinforcement learning.
Gotcha.
Anyone who wants to understand core concepts, the algorithms, the potential applications of RL, this is the place to start.
It's amazing to think that a book published over 25 years ago is still relevant. In such a fast-moving field like AI.
It speaks to the fundamental nature of their work.
Yeah.
You know, Barto and Sutton were able to articulate those fundamental principles of how machines can learn through trial and error. And those principles have held true, even as the field has advanced so rapidly.
It's more than just a textbook.
Yeah.
It's like a foundational text.
It is.
What about Barto's other publications?
Sure.
The essay mentions.
Yeah.
Quite a few influential research papers.
Well, one that really stands out is a 1983 paper he co-authored with Sutton and Charles Anderson titled Neuron-like Adaptive Elements That Can Solve Difficult Learning Control Problems.
Even the title sounds forward-thinking.
I know, right?
Neuron-like adaptive elements.
Yeah.
So were they already thinking about...
They were ahead of the curve.
Okay.
This paper was all about exploring how artificial systems could learn and adapt in a way that was inspired by how neurons work in the brain.
So even in those early days, they were thinking about building AI that was more brain-like.
Trying to bridge that gap between neuroscience and AI.
That's pretty mind-blowing.
It is.
And then there's another groundbreaking paper from 1995. Reinforcement learning with function approximation. Again, co-authored with Sutton.
Yes.
Okay, function approximation.
Right.
That sounds a little intimidating.
Well,
what's the basic idea there?
Think about it this way.
Okay.
As AI systems tackle more and more complex problems, the number of possible states and actions they need to consider grows exponentially. Trying to keep track of all that information can quickly become computationally overwhelming.
It's like trying to remember every single possible move. In a game of chess.
Exactly.
Your brain would explode.
And that's where function approximation comes in.
Okay.
It's a way for AI agents to simplify the problem by learning a compact representation of the value of different states and actions without having to memorize every single detail.
So instead of memorizing every single detail, it's about learning general rules.
That's the gist of it.
Okay.
This paper was a major step forward. Because it opened up the possibility of applying reinforcement learning to much more complex and realistic problems.
It's like they were giving AI the tools
to
handle the messiness and complexity of the real world.
Exactly.
So we've talked about some of Barto's big publications.
Right.
But what about some of the key concepts that he introduced?
Sure.
The essay mentions policy evaluation. What exactly is that?
Well, in reinforcement learning, a policy is essentially a set of rules that an AI agent follows to decide what actions to take in different situations.
So what is policy evaluation?
Policy evaluation is all about figuring out how effective a given policy is at maximizing rewards over time. It's like testing out different strategies to see which one leads to the best long-term outcome.
So it's like running simulations or experiments.
You got it. And based on the results of that evaluation, the AI agent can then adjust its policy, tweaking its strategy to try to get even better results.
So it's a constant process of learning and improvement.
Exactly. The AI agent is always trying to refine its strategies and find the best possible way to achieve its goals.
That makes sense.
Yeah.
The essay also talks about action value estimation.
Right.
As another important concept.
It is.
Is that related to policy evaluation?
It is, but it focuses more on the value of specific actions.
Right.
Remember, model-free learning means the AI agent doesn't have a complete understanding of the environment's rules beforehand.
Right.
So it needs a way to figure out which actions are likely to lead to good outcomes.
Okay.
Even when it doesn't have all the information.
It's like trying to choose the best move in a game.
Exactly.
When you don't know all the rules.
And action value estimation helps the AI agent do just that. It's about figuring out how good it is. To take a particular action in a given state without knowing all the ins and outs of the environment.
Oh, it's like weighing the potential consequences of different actions.
That's a good way to put it.
Okay.
And this is often done through what's called the Q function, which we talked about earlier. It basically assigns a value to each possible action in each state, estimating how much reward that action is likely to bring in the long run.
So it helps the AI agent make smarter decisions.
Yeah.
Even when it's in uncharted territory.
It does.
It sounds like action value estimation is key for making those model-free algorithms work effectively.
It is.
All right, and then there's another fascinating concept that Barto explored.
Okay.
Temporal abstraction.
Temporal abstraction.
What does that even mean?
Well, it has to do with how we think about actions in time.
Okay.
In traditional reinforcement learning, we often focus on individual actions that happen one after the other, like pressing a button, then moving a lever, then doing something else.
It's a very step-by-step approach.
Exactly.
Okay.
But in the real world, our actions often unfold over longer timescales.
Right.
We have goals that take multiple steps to achieve.
Like learning to ride a bike.
Precisely.
It's not just one action. It's a whole sequence of movement.
And temporal abstraction is about giving AI agents the ability to think about and learn these kinds of higher level actions or options, as they're sometimes called.
Okay.
It allows them to plan ahead and consider more complex sequences of actions.
So it's like giving AI a sense of strategy.
Exactly.
The ability to think about the bigger picture and how different actions might lead to that desired outcome.
And this is crucial for tackling more sophisticated problems, where the solution isn't just a series of simple actions, but a coordinated strategy that unfolds over a longer period.
It sounds like Barto was not only laying the groundwork for how AI could learn, but also how it could think.
He was.
Plan strategically.
Pushing the boundaries.
So his impact extends far beyond his own research.
It does.
He was known for being a fantastic collaborator and mentor.
He was.
Which is something I really admire about him. The essay definitely highlighted his long-standing partnership with Richard Sutton.
Right.
But he collaborated with a whole network.
Oh, absolutely.
Of brilliant researchers.
Chris Watkins, the developer of Q-learning, was one of Barto's students.
Okay.
And Charles Anderson, who we mentioned earlier, was another key collaborator.
Gotcha.
Barto had a real knack for bringing together talented people and fostering an environment of intellectual curiosity and innovation.
It sounds like he was a true leader.
He was.
Not just in terms of his research, but in his ability to inspire and empower others. His influence goes beyond academia, too. Right?
It does.
We talked about the applications of RL.
Right.
But I'm curious to hear more about how his work has impacted various industries.
Well, healthcare is a great example.
Okay.
It's a field that's ripe for disruption by AI. There's so much data.
Right.
So many complex decisions to be made, and the stakes are incredibly high.
And reinforcement learning seems perfectly suited to handle that complexity.
It does.
It's all about making decisions based on data and feedback, right?
Exactly.
So think about personalized treatment plans, for example.
Right. Oh.
Every patient is different.
Right.
So figuring out the best course of treatment is incredibly challenging.
It is.
So reinforcement learning algorithms can be trained on massive amounts of data, learning to identify patterns and make predictions about what treatments are most likely to be effective for individual patients.
It's like having an AI doctor that can analyze your entire medical history and suggest a treatment plan tailored specifically for you.
Okay.
Of course, it's still early days, and we're a long way from replacing human doctors entirely.
Right.
But RL has the potential to be an incredibly powerful tool in healthcare, helping doctors to make more informed decisions and improving patient outcomes.
That's fascinating. What about other fields?
Sure.
Where else is RL making a big difference?
Well, finance is another area where it's making waves.
Okay.
The financial markets are incredibly complex and volatile.
Right.
Trying to predict what's going to happen next is notoriously difficult.
Yeah.
Even for the most seasoned experts.
And I'm guessing reinforcement learning algorithms don't get intimidated by all that volatility.
Not at all.
Okay.
They actually thrive on it.
Right.
RL algorithms can analyze vast amounts of financial data, identifying patterns and trends that humans might miss. Right. They can learn to make trades, manage portfolios, and assess risk in ways that are incredibly sophisticated.
It's like having an AI financial advisor.
Precisely.
That can help you navigate the complexities of the stock market and make smarter investment decisions.
And because these algorithms are constantly learning and adapting, they can adjust to changing market conditions much faster than humans can.
I can see how that would be incredibly valuable.
It is.
In a world where financial markets are becoming increasingly unpredictable.
Right.
What about transportation?
Sure.
We've already touched upon self-driving cars.
Yeah.
But I'm sure there are other applications in that space too.
Oh, definitely.
Okay.
Self-driving cars are a prime example.
Right.
But RL can also be used to optimize traffic flow in cities.
Right.
Reducing congestion and making transportation systems more efficient.
So RL isn't just about individual cars driving themselves.
Exactly.
Okay.
It's about optimizing entire transportation networks.
And it can also be applied to improve safety on the roads.
Yeah.
For example, algorithms can be trained to detect and anticipate dangerous driving behaviors.
Exactly.
Helping to prevent accidents.
It sounds like RL has the potential to revolutionize how we get around.
Right.
Making transportation safer, more efficient, and more sustainable.
It's all thanks to the groundwork laid by researchers like Andrew G. Barto.
It is.
He truly was a visionary.
He was.
It's been an incredible journey so far.
Yeah.
Exploring his work and the far-reaching impact of reinforcement learning.
It has.
But our dive isn't over yet.
Right.
We'll be back in the final part.
Okay.
To explore Barto's vision for the future of intelligent agents.
Right.
Stay tuned. So we spent the last 2 parts of this deep dive really unpacking the world of Andrew G. Barto.
Yeah.
And his profound impact on reinforcement learning.
It's been quite a journey.
It has.
Yeah.
It's clear his work has had this ripple effect on AI, touching everything from self-driving cars to personalized medicine.
It has.
But what about his vision for the future of AI?
Right.
Where did he see all of this leading?
Well, Barto didn't just focus on the technical aspects of AI.
Oh, right.
He was deeply interested in the bigger picture. He believed that AI had the potential to not only solve complex problems, but also to enhance human capabilities. He saw a future where AI and humans could collaborate and complement each other's strengths.
So not a dystopian future where robots take over the world.
Not at all. Okay. Barto's vision was one of partnership.
Right.
Where AI could augment our intelligence and help us achieve more than we could on our own.
He often talked about the concept of intelligent agents.
Yeah.
So AI systems that could learn, adapt, and act autonomously.
Right.
But always with the goal of benefiting humanity.
Always with that goal in mind.
It makes me think of those sci-fi movies.
Yeah.
Where people have these AI assistants. That help them with everything. From scheduling appointments to solving complex scientific problems.
That's a good analogy.
Yeah.
Barto envisioned these AI systems that could not only perform tasks, but also learn and grow alongside us.
Okay.
Becoming more capable and versatile over time.
Adaptability was a key element of his vision.
It was.
Yeah.
He believed that AI systems needed to be able to handle the uncertainty and complexity of the real world, where things are constantly changing.
So it's not about programming AI with all the answers in advance.
No, it's about giving it the ability to learn and evolve on its own.
Right.
Kind of like how humans do.
Exactly.
He believed that that ability to learn from experience was crucial for creating AI that could truly complement human intelligence.
And along with that, he emphasized the importance of long-term reward optimization.
He did.
We talked about that earlier in the context of reinforcement learning.
Yeah.
But how does it apply to this broader vision of AI?
Well, Barto recognized that AI systems shouldn't just be focused on short-term gains or immediate rewards.
Okay.
They needed to be able to consider the long-term consequences of their actions, just like we strive to do as humans.
So it's about making sure AI is not just smart, but also wise.
That's a great way to put it.
So this all sounds very forward-thinking.
It does.
But some of these ideas, like artificial general intelligence or AGI, are still quite controversial.
Yeah.
Some people think it's inevitable. Others are more skeptical.
Right.
Where did Barto stand on the possibility of achieving AGI?
Barto believed that AGI was a worthy goal.
Okay.
But he was also realistic about the challenges. He saw reinforcement learning as a potential pathway to AGI.
Right.
But he acknowledged that we still had a lot to learn about how to create AI systems that possess the same general cognitive abilities as humans.
So what did he see as some of the biggest hurdles standing in the way of AGI?
One of the key challenges he highlighted was this difficulty of imbuing AI systems with common sense.
Right.
You know, humans take common sense for granted.
Yeah.
But it's incredibly difficult to program into machines.
Like all those unspoken rules and assumptions that we just intuitively know how to apply in different situations.
And then there's the challenge of creativity and innovation.
Right.
You know, current AI systems are very good at following patterns and rules.
Okay.
But they often struggle to come up with truly novel ideas or solutions.
So we need to figure out how to give AI that spark of imagination that humans seem to have.
That's the holy grail in many ways. We need to understand how to create AI systems that can think outside the box, challenge assumptions, and come up with truly original ideas.
That sounds incredibly difficult.
It is.
Okay.
But Barto believed that by studying human intelligence and drawing inspiration from fields like neuroscience and cognitive science, we could make progress towards that goal. He was a firm believer in the power of interdisciplinary research.
It sounds like his vision for the future of AI was both ambitious.
It was.
And grounded in a deep understanding of the challenges involved.
Yeah, he was always pushing the boundaries.
Okay.
But he never lost sight of the importance of ethical considerations.
Right.
He believed that as we create more powerful and autonomous AI systems, we have a responsibility.
Yeah.
To ensure that they're aligned with human values.
So it's not just about making AI smart.
No.
But about making sure it's used for good.
Exactly.
And that's why he placed such an emphasis on adaptability and long-term reward optimization.
He believed that if we can create AI systems that are capable of learning, adapting, and considering the long-term consequences of their actions, we'll be much more likely to create AI that benefits humanity as a whole.
It's a hopeful vision for the future.
It is.
But as we've discussed throughout this deep dive, there are also risks involved.
Of course.
So how do we balance the excitement of AI's potential?
Yeah, that's the question.
With the need for caution and responsibility.
It's a question that researchers and policymakers are grappling with every day. I think the key is to approach AI development with a sense of humility, recognizing that we don't have all the answers. We need to be open to different perspectives, willing to course correct, and always prioritize human well-being above all else.
It's about remembering that AI is a tool.
It is.
And like any tool, it can be used for good or for ill.
That's right.
It's our responsibility to ensure that it's used wisely.
Well said.
Yeah.
And I think that's a fitting way to sum up Andrew G. Barto's legacy. He was a brilliant scientist, but he was also a deeply thoughtful and ethical individual. He believed in the power of AI to make the world a better place. And he challenged us to approach this technology with both ambition and wisdom. His work will continue to inspire and guide us as we navigate this complex landscape of artificial intelligence.
It's been an incredible journey exploring his world.
It has.
From the fundamental algorithms of reinforcement learning to his vision for intelligent agents, Barto's contributions have left an undeniable mark on the field of AI.
They have.
And who knows, maybe someone listening to this deep dive will be inspired to pick up where he left off.
I hope so.
And continue pushing the boundaries of what's possible.
That would be a fitting tribute to his legacy.
Well, thanks for joining us on this deep dive.
My pleasure.
Into the fascinating world of Andrew G. Barto.
Yeah, absolutely.
Until next time.
Yeah.
Keep exploring. Keep learning.
Right.
And keep imagining the possibilities.